Hi everyone, welcome to the AIML Study Circle presentation by Jaymeet Vasave for video recommendation system. This is the sixth of the one and use case number 5 as he will go back and you can look at the videos which are there on the Open Tech forum 1140 I believe the number under which all other recordings are there. So welcome Jaymeet and Mamta and all others who like to focus on the AIML. So Jaymeet, go ahead, take the floor, it's yours and move from there. Thank you.
So, hello everyone. My name is Jaymeet Vasave, and we have been discussing these use cases. So, today's presentation is about video recommendation system. Uh, before starting this, I will like to uh, talk a bit about how we are going to discuss it. So, it's not the whole thing. We are going to discuss the system within some set of boundaries and with having some kind of assumptions in mind. So let's get started for video recommendation system. So the assumptions and constraints regarding the system are the ML system will load the video recommendation system when a user loads a homepage. So we are not discussing selecting uh, whether the user is watching a video and then relevant videos are recommended to them, but rather when the user loads a homepage, what kind of video recommendations will the user get? So moving further, we have a business objective (BO) is to increase the user engagement. Since the YouTube is a global service, users are located worldwide, and users and videos are in different languages. The playlist feature does not exist. So as I said earlier, we are not discussing the whole video. So there are different features that we will not be including in this with playlist feature as well. Then we are assuming that we have 10 billion videos on platform. The recommendation to users should not take more than 200 milliseconds, or we can say that basically it is fast. It has to be fast in serving the user, and all the representations used further will be used as a user video pairs. So this is in reference to further topics when they are discussed. So starting with clarifying the requirements. So to design a homepage video recommendation system, the business objective is to increase user engagement. Each time user loads the homepage, the system recommends more engaging videos. Users are located worldwide and videos can be in different languages. We have 10 billion videos and system should recommend them quickly. So framing the problem as an ML task or translating the business objective to ML objective. So defining the ML objective, there are different approaches to translate a business objective into ML objective. So some of them are maximizing the number of clicks. The recommendation system is designed in a way to maximize user clicks. The drawback being clickbait videos, which reduces the user satisfaction and engagement over time. The maximize a number of completed videos. So recommending videos that the user is more likely to complete, but the drawback to it being the model will start suggesting shorter videos as it is easier to watch and complete. So moving further with maximize total watch time, recommending videos that the user spend more time watching, and maximizing the number of relevant videos produces relevant videos for user, but engineers or product managers have to define relevance. So this depends on users implicit and explicit reactions like sharing and or disliking the video or watching half of the video. So once relevance is defined, when we can construct the dataset to train the model to predict a relevance score between a user and a video. So we'll be using the maximize the number of relevant videos as we have more control over features to use, and does not have drawbacks of other topics discussed earlier, options discussed earlier. So this is the specifying the input and output to the system. So input is a user, or we can say user's profile, and depending on the user profile, the model has to load recommended videos to the user. So choosing the right ML category, we in recommendation system we have personalized way and non-personalized way. So non-personalized way is simply the rule-based rule that is set by the admin, and only specific information is displayed to the user, and not all of them are displayed. But in personalized, we have content-based filtering, collaborative filtering, and hybrid filtering that we'll be discussing in detail further, as our use case is based on personalized recommendation system. So starting with content-based filtering, and this technique finds video to recommend new videos similar to those relevant in the past. So for example, if a user has watched cooking videos, similar cooking videos will be recommended to the user. So in the diagram, it shows the same thing, that video X and Y were liked by user A. And because it was liked by user A, similar video of to X and Y was Z, which was recommended to user A. So So advantages to it are less dependency on making video profiles for user, as a video profile depends entirely on its features. So ability to capture unique interest of user, as videos are recommended on user's previous engagement. The disadvantage to it being difficult to capture users' new interest, and using the method requires domain knowledge, as we often need to engineer features manually. So collaborative filtering. Collaborative filtering works with the idea that similar users are interested in similar videos. So to use user or user based CF, or video or content based collaborative filtering similarities. So in the diagram, you can see that user A and B have are similar users, and video X and Y are watched by both user A and B. But B has also watched video C, which is liked by user B. So that is the reason user Z will be also recommended to user A. So the difference between content-based filtering and collaborative filtering is that collaborative filtering doesn't use video features and exclusively depends on users' past interaction for video recommendations. So the advantages of collaborative filtering, it does not rely on video features, so it doesn't need domain knowledge to engineer feature from videos. And so because collaborative filtering does not use video features, and they are faster and less compute intensive, and easy to discover users new area of interest, as the system can recommend new videos about new topics that similar users have engaged with in the past. So the problem with collaborative filtering is it depends on uh, user video interaction, but it faces a cold start problem. So cold start problem is basically what to recommend to new user on the platform. So that's when the collaborative filtering does not work well, and does not know what kind of recommendations to make to a new user. The second disadvantage being to find niche interest of users and to recommend them videos. So comparison for content-based filtering and collaborative filtering. Content-based filtering is good at handling new videos, but collaborative filtering is good at discovering new videos for the user. It does not require domain knowledge to engineer the features, and it is as it's less compute intensive, so resourceful in handling the resources, or using the resources. It has more efficiency than content-based filtering. So moving further with hybrid filtering, which uses both content-based filtering and collaborative filtering. So in the hybrid filtering can be done in two ways. One is parallel and one is sequential. So in parallel, the the input is taken by both a CF-based recommendation as well as the content-based recommendation, and their given results are combined and given as the recommendations. But in the sequential, first the input is taken by collaborative filtering based recommendation, and then those are narrowed down more or filtered more by the content-based recommendations and given as an output. So in practice, sequential hybrid filtering is used by companies. So video features allow system to recommend relevant videos based on users' past engagement. The collaborative filtering helps users to discover new areas of interest. So because of those advantages, we'll go ahead with hybrid filtering. So now, talking about the data that we have in hand. So in data engineering, we will discuss a bit about the video about the data about the video data, the user data, and the user and video interaction. So so in data about the video, we have a video ID, the length of the video, the manual tags and manual title, which are obviously given by the user or the uploader, and the another likes, views, and languages used in the video. Moving further with the user, we have most of we have the information about the user that most of the social media platforms collect from their users of age, gender, city, country, language, and time zone, etc. So moving further with user video interaction, we have a user ID and video ID, their interaction type, and if the interaction type contains any kind of interaction value, like you can see in the impression, watch, search, and comment, those interaction values are collected, and along with the location and timestamp. So in feature engineering, we'll be talking about video features and user features. In video features, we have video IDs. So IDs are categorical data, and to represent them by numerical vectors, we use embedding layers. Duration is how long the video is going to last from start to finish. So some users prefer shorter videos and some users prefer longer videos, and that's where the duration of the video can help us. The language used in the data, as some users prefer some particular languages, so it helps in that. And language being a categorical variable and takes on a finite set of discrete values, we'll use an embedding layer to represent it. Going further with the titles and tags that are in the video, they are used to describe a video, either added by user manually or implicitly added by a standalone ML model. So they are valuable predictors as title of a video. For example, how to paint a mountain or how to make a pizza implies the video is for drawing and cooking respectively. So for tags, we can use a lightweight pre-trained model of continuous bag of words. And for title, as the title contains contextual information, we'll be using the model BERT for it. So this is what the whole feature engineering overview of the feature engineering looks like. So videos data regarding the video of language, video ID, duration, titles, and tags are converted into their respective embedding or generated their respective embeddings. And for titles, because we want the contextual information, BERT is used, and for tags we are using continuous bag of words. All of those Embeddings are concatenated further for concrete and concatenated features. Moving further with user features, so we'll be discussing the user demographics, contextual information, and user historical interactions. So for user demographics, as you can see, it's details regarding the user. So user ID, age, gender, language, city, and country, and all of those embeddings are concatenated further and in the concatenated features. So contextual information regarding the user. So what time of the day the user likes to watch the video. So for the example, you can see that a working professional looking to improve themselves can watch more educational videos at evening. The device is used by the user as mobile users comparatively prefer shorter videos compared to desktop users. The day of the week, depending on the day of the week, the users can have different preferences for the video. And similar to the uh, to previous one, we have different embeddings being created for the day of the week, time of the day, and device. For time of the day and device, both have 1 hour encoding. But before 1 hour encoding in time of the day, the it is bucketized first and then used for one hot encoding. So using the user historical interactions. So while discussing the user historical interactions, we will be asking two questions of on both the topics, which is why are they important and how to use it. So the search history, why is it important? Because it looks for what user has looked in for the past in the past, and users' past interactions and past behavior is often an indicator to the future behavior. So using BERT as a pre-trained model to map each search query to an embedding vector, but a user's search history is a variable sized textual query. So to create a fixed sized feature vector summarizing all the search queries, we average the query embedding. So moving further with the liked videos and watched videos, and why are they important? Because liked videos or and watched videos are indicators to determine what type of content user is interested in, and how to use it is by using embedding layers. Video IDs are mapped into embedding vectors. So similar to search history, as we have created using BERT, we created the embeddings for search history. We will be creating embedding for fixed size embedding for uh, the liked videos, watched videos, and impressions as well. So this is the whole user video interaction looks like. The respective embeddings of impressions, watched videos, and liked videos are created by the embedding layer. But for us, if we want to have contextual information, the search queries embeddings are created using BERT, and all of them aggregated together to the concatenated features. So moving further with the model development, the common embedding based models for content based filtering or collaborative filtering based have are matrix factorization or two-tower neural network. So we'll be starting with matrix factorization. So first, for matrix factorization, we have to understand about feedback matrix, which encases or captures the user's opinion about the video. So you can see in the diagram below that the video that the user has interacted with has the value of 1. So that is how the feedback matrix is formed. So a feedback matrix is built on users' opinion about the video and interactions such as likes and shares. So 3 ways to find how user finds recommended videos relevant are explicit feedback. So it tells us, so explicit feedbacks are basically what user explicitly liking the video. But the major problem with explicit feedback is that the users don't always interact or give explicit feedbacks, and due to those reasons, the matrix formed is very sparse, and it's difficult to train an ML model on it. So matrix factorization, sorry. So for the implicit feedback, we shows the implicit indications of users' interest in the video, like click or watch time. With implicit feedback, more data points are available, training a better model, but cannot directly reflect users' opinion. And similar to explicit feedback, it can be noisy. So combination of explicit and implicit feedback can be used, which combines both of them using heuristics. So the wiki's definition to heuristic uh, is a technique designed to problem solving more quickly when classic methods are too slow for finding an exact or approximate solution. Or regarding ML, the heuristics are cognitive shortcuts that are used to simplify decision making processes. So we'll be choosing the combination of explicit and implicit feedbacks as it aligns well with the ML objective to increase the user engagement by giving more relevant videos, and combination of both explicit and implicit is the best choice for us. So matrix factorization model, it is a simple embedding model which decomposes the feedback matrix into lower dimensional or user embeddings and the video embeddings, and the distance between both of those embeddings shows their relevance between them. Matrix factorization training, for training we try to produce user and video embedding matrices, which is good approximation to feedback matrix. So to learn this, first the it first randomly initializes two embedding matrices, and iteratively optimizes the embedding matrices to reduce the loss function between predicted scores and feedback matrix. As you can see in the image in the diagram below, that we have predicted scores which are somewhat similar to the feedback matrix or the ground truth. So for measuring the difference between the ground truth values and the predicted scores, we'll have to discuss the loss functions. So we'll be discussing the loss function for matrix factorization. So there are three loss functions. We'll be going over them uh, next. So square distance over observed pairs. So the feedback matrix and predicted matrix you can see in the uh, diagram below, and the formula for calculating the loss. So Aij is the entry of for user I and j where it intersected, and UI is the embedding for user I, and Vj is the embedding for video j. So And so the loss function basically measures the sum of square distance over all the pairs of observed, which means non-zero entries in the feedback matrix. But the problem with this is it will only consider the observed pairs, and the model is not monitored or uh, penalized on making bad predictions or for unobserved pairs, and unobserved pair is not measured at all. So this is not good, and the embeddings created for observed pairs for non-zero might work, but for same for unobserved pair might not work. So square distance, so we're moving further with the different one. So square distance over observed and unobserved pairs. This loss function assigns the negatives to unobserved pairs and assigns a zero to the feedback matrix, which solves the issue of not penalizing model for bad predictions in previous loss functions. So the major drawback here is it is considering both observed pairs and unobserved pairs, but the value of unobserved pairs, or there are many unobserved pairs compared to the observed pairs, which leads to poor generalization of unobserved pairs. In a way, you can say that unobserved pairs are dominating here. So moving to the third loss function, the weighted combination of squared distance over observed and unobserved pairs. So we can see that in the diagram below, we have the formula for it. So in the first summation, we have uh, the first is the summation for the observed pairs. The second is the summation for unobserved pairs with W. So W is a hyperparameter which ensures that one does not dominate over the other. And and we have to properly tune the W, which can give us a good results. So a properly tuned W works best in the practice. So we'll be going further with this method. So matrix factorization optimization. So for training an ML model, we require optimization algorithm. So stochastic gradient descent is one, which is used for minimizing the loss, and weighted alternating least squares, which is specific to matrix factorization. The order in which the walls or weighted alternating least squares work is we fix one embedding matrix of, let's say, user, and optimize the other embedding for video. We fix another embedding for video this time and optimize the embedding for user, and we repeat until the walls converges. It converges. So walls converges faster and is parallelizable. So we'll be using walls for false. So moving further with matrix inference, a dot product for a similarity measure of a random user embedding and a video embedding is calculated to find the relevance between them. So so just a second. So, so depending on the video, the interaction of the user and the video, we are getting the feedback matrix. But the problem with that this is that the matrix factorization uses a user video interaction only. So it is to be used in collaborative filtering as well. So it is only used in collaborative filtering. So the pros and cons to matrix factorization is the advantage is being faster training speed due to having two matrices to learn. The serving time is also fast as learned embeddings are static, meaning once we learn them, we can reuse them and do not need to transform the input at query time. The disadvantage is being it relies on user video interactions only and does not consider other important features as a user's age, language, location, etc., which can improve our recommendation quality. So, and handling new user is difficult as there is no user video interaction data. So matrix factorization cannot determine whether a video is relevant to a user by computing the dot product between the embeddings. So and the another way of another architecture is a two-tower neural network. The two towers in the neural network are one is for a user encoder for creating user embeddings. Another one is a video encoder for creating the video embeddings. So the distance between them will show the relevance between them. So constructing the dataset for a two-tower neural network, we construct a dataset by labeling the positive and negative from different pairs based on users' feedback. So positive if the user has explicitly liked the video or watched the video at least half of it, or a negative we can for a negative we can randomly choose the video that were non-relevant for to the user, or the user has explicitly disliked it. So while constructing the dataset, user only finds small fraction of videos relevant, making more negative pairs or making it majority than positive pairs, making positive pairs minority, which constructs an imbalanced data set. So there are there can be different ways to treat an imbalanced data set. Two of them are you can scale the minority up, or you can duplicate the minority enough with roughly the same size of the negative or the majority of the dataset consists of, or you can cut down the majority uh, by the size which is roughly the size of the minority. So these are two of the ways imbalanced data set can be treated. So choosing the loss function for the two-tower neural network, choosing the loss function since two-tower neural network is trained to predict binary labels, it can be categorized as a classification task, and because of that, we can use cross entropy as a loss function. So two-tower neural network inference time at inference. So at inference time, the video embedding will be used to find the k most relevant videos, making it a classic k nearest neighbor problem. We will use approximate nearest neighbor to find the most relevant videos efficiently. So two-tower neural network is used in both content-based filtering and collaborative filtering. But when used in collaborative filtering, the video encoder is used as an embedding layer. The pros and cons to a two-tower neural network: the model accepts user features such as age and gender, which are used to make better recommendations. As user features are used, the model handles new users very easily because the model considers the user's age, gender, location, language, etc. So disadvantage is being the model needs to compute embeddings at query time, making it slower. If you use content-based filtering, the model needs to transform video to video embedding, increasing the inference time. The training is more compute intensive as a two-tower neural network has more learning parameters than matrix factorization. So, comparing the matrix factorization with a two-tower neural network. So the training cost for matrix factorization is better as it is less compute intensive, and because it takes lesser parameters, the inference time of matrix factorization is also fast, and matrix factorization uses static embeddings and are pre-computed and can be reused as well. But two-tower neural network works well with cold start problem of, or when a new user has started using the platform, and the quality of recommendations are better in two-tower neural network as it can take more parameters. So for discussing the evaluation of the model. So starting with the offline metrics of it. So first is a precision at k, which measures the proportion of videos among top k relevant recommended relevant videos recommended using different values of k. The second one is a mean average precision, as measures as we are dealing with binary. It is a good fit, and it measures the ranking quality of recommended videos. So the third one is diversity. So this metric measures how dissimilar recommended videos are to each other. It is an important metric to track or track as users are interested to watch diversified videos. To measure diversity, calculate the average pairwise similarity between the videos in that list. And lower average similarity indicates the diversity of the list, and indicates a diverse list. And we have to and we are not depending on diversity alone, as diversity in the list is only useful if users find it useful, meaning we have to use a diversity metric with other metrics to ensure relevance and diversity. So we cannot so basically we cannot recommend videos to users that that the user has not found it useful. So such kind of uh, um, diverse recommendations can actually keep the engagement low. So diversity has to be used in combination to the above mentioned precision at k and mean error precision. The- Moving further with the online evaluation, so first is click-through rate, but the problem with it is it will only measures the click, and uh, and it cannot measure the clickbait videos, which can decrease the user satisfaction for the platform over time. The number of completed videos shows us how many system recommended videos the user watched, the total time user spent time watching recommended videos, and explicit user feedback, which is liking the video, disliking the video. So at deploy time or the serving time, at serving time, the system recommends the most relevant videos from billions of videos to a given user by narrowing down the selection. So we will use a prediction pipeline which is efficient and accurate at serving request. But while using a prediction pipeline, there are two issues that can occur for the models that we have discussed earlier, which is if we are dealing with the first being we are dealing with billions of videos. So the serving speed would be slow if we choose a heavy model because it has many features to take in as an input. And if we choose a lightweight model, the quality of recommendation will not be good, or will not be of high quality. So the one solution to it is to use a one model in multi-stage design. So the in first stage, the lightweight model narrows down the videos called candidate generations. In stage two, the heavier model that accurately scores and ranks the video scores and ranks the video, which is called scoring or ranking. So for this, we will be also discussing the candidate generation, scoring, and re-ranking. So this is what the candidate generation and uh, scoring looks like in multi-stage process. So candidate generation will generate from billions of videos to thousands of video interact while interacting with the user features, and depending on the on and taking into consideration some more parameters, the scoring will be done by a heavier model. Means it will take more parameters from the user's profile, and it will narrow down the thousands of videos to hundreds, and the re-ranking services will further uh, uh, apply more constraints on the list and ranks the video. So the thousands of videos will be narrowed down to dozens of videos and will be displayed to the user. So candidate generation, discussing the candidate generation, it helps us to narrow down the videos from billions to thousands. We focus on efficiently narrowing down the videos that accurately narrowing it down while not. So in candidate generation, we are basically efficiently trying to create a list of videos and not bothering more about accuracy. And For keeping the candidate generation fast and handling new users as well, we will choose a model which doesn't rely on video features. So we'll be using a two-tower neural network. So in practice, companies will choose more than one candidate generation for improved performance of recommendations. So that's what's happening in the diagram on the right, that user may want to watch different kind of videos for different reasons. The user can like to watch the videos because of its popularity. And there are certain relevant videos that we are already uh, discussed, that the home feed will be recommend will be the videos will be recommended on depending on the user's profile, and the trending videos that are in the locality or in the country in general. So different candidate generations give us a more accurate, or we can give more recommendations to user with high ranking quality. So scoring. After candidate generation, videos retrieved are used for scoring, also known as ranking. So scoring takes the user and candidate videos as input and scores each video to output a ranked list of videos. So in this stage, we will prioritize the accuracy. First we talked about efficiently creating the list and didn't bother much about the accuracy. But this time we'll be prioritizing the accuracy for giving the users the relevant recommendations. So in this also we'll be using a two-tower neural network, but it will be heavier model as it will be taking more parameters for ranking the video. So the output of the candidate generation will be the input to the scoring, and the user features again will be taken into consideration for narrowing down the thousands of candidate videos to the dozens of videos. So re-ranking, and this component re-ranks the videos by adding more criteria or constraints. For example, we may use a standalone model to determine the clickbait videos. So few things to keep in mind when building a re-ranking component is region restricted videos. As you might have come across that there are certain videos that are not available for certain countries, or certain videos are not available in our own country. Video freshness, the videos spreading misinformation, duplicate or near duplicate videos, and fairness and biases in the recommendation system. So we have discussed the recommendation system, and there will be certain challenges that it may have faced, like cold start problem we discussed about. So let's see how the model that we have discussed will tackle the challenges. So at serving speed for serving the user quickly, it is important to recommend videos fast. So dealing with billions of videos and recommending them efficiently and accurately can be challenging. So to address this, we used a two-stage design using lightweight model for stage one for candidate generation, for dealing with billions of videos and narrowing down to thousands. For second is precision of the recommendation videos. To ensure precision, we include heavier model to rank videos which relies on more features, including video features. So using a heavier model will not affect the serving speed here, as only a subset of videos are selected after the candidate generation. Mo- Also, we discussed about the diversity. So to ensure diverse recommendations to users, we used multiple candidate generations. The co-start problem that we discussed earlier. So we lack the user interaction data for user interaction data on the platform if a new user has started using the platform. So for new users, we can there are still the recommendations are made to the new users based on the features of age, gender, location, and language, and other such features. And as the users start using the platform, the interaction data is collected to give the better prediction, better recommendations to the new user. Similarly, for videos, the videos for new data, we don't have much of the interaction data of the video because and to solve that we can recommend new videos to random users, and as the video gets interaction values, we can we can know what kind of recommendations to make and or what kind of uh, u- uh, users to show that particular video. So training scalability of the whole model. So it is challenging to train models on large data sets in a cost-effective manner. In recommendation systems, new interactions are continuously added, and the system has to quickly adapt to make accurate recommendations. To quickly adapt to new data, the model should be fine-tuned, and our model is based on neural network and can be easily fine-tuned. So training scalability basically talks about the adaptations that the model has uh, to ensure well in for the future purposes, and what kind of data or changing habits or viewing habits of users has to be adapted by the model quickly. And for adapting those changes, the model is to be able to be quickly fine tuned. So to summarize the whole use case that we have talked about. So first we started with clarifying the requirements, where we talked about what kind of recommendations the user will get when the user opens their home page. Then we talked about framing the problem as an ML task. So basically converting the business objective of increasing the user engagement to the ML task. And for that we discussed a few techniques which were maximize the number of user clicks, maximize the number of completed videos, maximizing the number of relevant videos, and maximize the number of watch time, where we went with maximize the number of relevant videos. Then we specified the input and output, which the input was the user profile, and the output were the recommended videos based on different features. And then we discussed about the ML category. One was non-personalized, and the other was, as our use case was focused on personalized, we discussed about content-based filtering, collaborative filtering, and hybrid filtering. Then we Then we discussed about data preparation. In data preparation for data in data engineering for data preparation, we discussed about the user data, video data, and user video interaction data. For feature engineering, we discussed about the video features, which contain video ID, duration, language, titles, and tags. User features, we discussed about demographics, uh, contextual information, historical interactions, like search history, like videos, watch videos, and etc. For model development, for model development, we discussed a matrix factorization and two-tower neural network, where for both we discussed about the loss functions, their optimization algorithms, etc. For matrix factorization, we discussed about the feedback matrix, where explicit feedback, implicit feedback, and combination of both. And we used a combination of both explicit and implicit feedbacks. For training loss in matrix factorization, We discussed about squared distance over observed pairs, observed and unobserved pairs, and the weighted combination of both. For optimization algorithms and matrix factorization, we discussed about stochastic gradient descent and weighted alternating least squares, where we went with weighted alternating least squares as that is specific to matrix factorization. For evaluation of the models discussed, for starting with offline evaluation, we we mentioned precision at k and mean average precision, and for the overall diversity for the recommended videos, we mentioned whether that the diversity has to be used for both precision as well as map, as a diverse video, if the user is not interested in, is of no use to us. For online evaluation, we have a click-through rate, number of completed videos, total watch time, and explicit user feedback of liking, dislike, or disliking the video. For serving, at the time of serving, we discussed about the candidate generation and using a lightweight model for it. Then scoring for a uh, heavier model, which takes more input, more parameters as input, and then re-ranking adds more constraints, which keeps on narrowing down and gives users some of the relevant videos out of starting from the billions of videos to dozens of it. So, and we also discussed about the challenges that the system can face, and how it is going to tackle it. So we discussed about the serving speed, precision at which the recommendations will be made, the diversity in the list, the how it will deal with the cold start problem, and the training scalability of it. So even though we have discussed this whole use case, and there are many different things that can be further added, or should be discussed more about, and should be added into the system for a more accurate predictions, or a more improved model overall. So there are uh, there are these 4 points, which is biases may be present in recommendation systems. There are important considerations related to ethics when building a recommendation system. So basically, sticking to ethical norms, considering the effect of seasonality. So viewing habit of users can change depending on the seasons, or certain videos can get more views depending on the season that is going on, or certain concert videos or concert registrations can also go up in certain seasons. So that is what we are talking about, the effect of seasonality to be considered, and how to benefit from negative feedback such as dislikes. So we have not talked much about dislikes here, but negative feedback such as dislikes can also help us improve the recommendation system. So this was it for the YouTube's recommendation system. Thanks a lot, and thanks a lot for listening.
Jaymeet, excellent presentation. Uh, I'm stumped now. I don't have any questions, but it was a good one, and I think you handled it well. And we look forward to further next session on event recommendation system. But before that, let me give the handle to Mamtaji and Amina and all if they have any questions to ask. Yeah, go ahead, Mamta and Amina or Nikhil, over.
Yes, Jaymeet, it was a very nice presentation. Uh, Next time when you are explaining all these concepts, like you are using this um, gradient descent and all that, if possible, also include the complexity parameters. I mean, just say it is exponential complexity, or it is time complex, or it is space complex. Just mention those things. So we as a
Okay.
researcher, if something we come across, oh, it's logarithmic complexity, good. We should
Yeah.
try applying this somewhere. I said, no, no. So if you have read in detail, you just try to, even in one line is fine. It just gives us a hint.
Okay, sure, ma'am.
Huh. And one thing I observed, I mean, it just struck me. We can use with this video recommendation or even text recommendation, anything. You know, when we have a large data set,
Yes.
augmentation can be used when we have low data set, right? So we
Yes.
use, but when we have a very large data set and we have to filter something relevant to our research, then this becomes useful, particularly image processing or video processing, and there's very large data and we want to filter it down for specific purpose, right? So this itself becomes a subtopic to a larger topic.
Yeah.
Yeah, so that, I mean, I was thinking on those lines. This is a full-fledged subject, this is a full-fledged topic, but it can be used as a subtopic to something and for different purposes. If, for example, if a doctor is going through some scan or some image, and he points to a particular place where, okay, this is a tumor or this is some disease portion of the entire image, so that becomes an input. And further, when we want to filter down other images or videos, his um, his interaction with that image becomes the input, becomes the recommendation to other images. That was my line of thinking when you were presenting.
Yeah. Actually,
So,
the use case are very diverse for recommendation systems. Normally when the recommendation systems are talked about, only social media is said, and other is e-commerce websites for recommending similar items in the shopping cart.
yeah, but
So
that is commercial applications are not there. No, we have so
yeah,
many other
yeah,
applications.
yeah, exactly. That's what I'm talking about. That yours was a bit different to it.
Approach, huh? I
Yeah.
mean, I was thinking on different lines. Prakash sir, what do you have to say on this?
Yeah, I think the commercial ones, most of them they talk about e-commerce and then recommending the videos and all. But when it comes to nitty-gritty content details, example as you mentioned in healthcare, if you have an image scanned image
Hmm.
and you want to get into that, the algorithms are quite different and databases are very different. So
Hmm.
modeling there is generally started with a transformer. That is, you already have something and then you apply it to something different, and
Right.
whatever the delta is there, that you apply. So
Hmm.
that is very specific to uh, more towards radiology, more towards scan, more
Yeah.
towards. So healthcare has a really different approach to it, including our virals and
Yeah.
COVID, and also healthcare is really really hard. It requires subject matter expertise, and
Exactly. Domain
uh,
expertise.
I don't think that at least Jamie does not have that medical background, right?
No, I'm not talking about Jaymeet having this knowledge. I was
But
just thinking that
yeah,
this
in
could,
general,
video recommendation itself becomes a subtopic. Like for example, in shopping, if I click on a particular cloth type or dress or shoes, so then
correct,
that becomes like next time like, when I come to the site, it will keep on popping those type of shoes or those type
correct,
of dresses. Yeah?
correct,
So
correct, correct, exactly.
now, similarly, when we have some images where doctor is explicitly mentioning that this is the region of interest, right?
Hmm.
When some other images where we are not aware of, okay, this can be region of interest, that recommendation used by the previous scans during the previous scan becomes the input to the non-known
Yes,
scans.
correct.
What I
So there is collaborative versus uh, contextual, right? So,
uh-huh.
so I think yes, you are mentioning that the contextual aspect of it, especially if it is recommended by a user,
Uh-huh.
then the image recognition for that. should follow that as a high weighted rather
Huh.
than, so priority should be given to those which are able
Yes.
to determine
Huh.
similar example. Let's say let's say we are looking for a diabetic and you are able to identify that for the diabetic, if you find that the liver has certain image and that
Huh.
gives us the clue, then
Huh.
that may be used for other places in similar
Huh.
what you call demography, etc. Correct?
Hmm. Yeah.
That is very, very relevant, I think. So these are
So,
contextual and they can be, instead of augmenting, like we said that we try to reduce, here you can
huh.
try to use that as a precision
Huh. Huh.
and to add more value to the model.
Yeah, yeah. I mean, obviously, a lot of other things will go into it for
Yeah,
filtering and all that.
correct.
But I mean, it's a general thought process that okay, this.
It's a fantastic. It's a good idea, and I think we will have to catch somebody in. What about Amina? What are you doing in this area? Any specific on the medical side, or is it more on the anything specific you are doing, which we can probe into and give you some ideas on that?
I mean,
See you brought the good like example. I'll tell you. I was stumped today when I something.
Hello, sir.
Go ahead. Do you have any specific questions before I talk about? So, Mamta madam brought us to the topic that if you have a tumor or something, then if you know some doctor pointed out, then that can be used as a contextual priority for
Yes,
us.
sir. Yes, sir. Actually, I had Dr. Mamta.
Mhm.
The overall general idea actually that she suggested is really relevant in a sense that if we are able to do that in these commercial sites and everything, then we should be able to have the same idea in medical or just anyway because it's the whole idea is having something that it's of a certain region and then making sure that you find pop-ups of that thing all around whatever that you are putting it in. So I think in general it will come with a lot of work, but it's a very good general idea.
Mhm.
Yeah.
And so, you need anything in your area which you can talk to Jaymeet. Maybe he can help and maybe help in trying to research and give you the inputs and all. That will be fantastic.
My area is under computing medical health, but so far we are not really in. We haven't gotten deep down. I think if we had started with the databases by now, I would have a specific ask
Correct.
for him
Correct.
to help me. But I will do so in the near future as we keep progressing.
Sure. Medical databases are there are many many databases which are used, and I think I also came across. I'll just point out some of the things which I had seen people doing, especially in this area. Uh, that brings me to today. I was stumped when I went. I was doing some online filling of some Ayushman Bharat card.
yeah,
Okay.
yeah, yeah.
And then what happened? The system is asking me, give me image, give me an Aadhaar card, give me PAN card, give me the image. I gave all that. Then it comes and tells me that, oh, this is not of proper size. I want for this size and this size. So
Mm,
then assume that I give. I have not been able to give it. Now thought process ran into my head that if I give it, can it automatically recognize that this is this person and this is the correct, and therefore I should approve it, or it will go through the manual processing. I have not tried it, but I want to feel through. If it is going through manual process, this is a very good AI candidate basically. If one
Mm,
can automate the because they do have the Aadhaar database, right? So they know the person, and you can
mm,
always age the image. If the person has aged after 5 years before they took, they can always age as they do in DMV and all, Department of Motor Vehicle and all. They do it. They can issue a license by just aging the photograph. So
mm,
maybe that's a automation problem, but it does use AI, and that if some startup comes up and says that all India, all over India, for all the such things, we'll be able to help you, that will be amazing. It will be a breakthrough for. Of course, it has impacts on the jobs, but nevertheless, technology is technology. It may help. So even a simpler technology than uh, much complicated. can actually solve the problem, lot of problems.
Yes, sir. I would like to jump in.
Yeah, yeah, sure, go ahead.
Yeah, yeah. So actually, the point you're talking about, right, automation using an image, that
Mhm,
is already in use at the airports by the means of DG Yatra, and
mhm,
so it's not really very old, but it I had used it last year for the first time,
mhm,
where I had to upload my selfie, and it
mhm.
took my Aadhaar credentials. Okay,
Ah, oh my
so
God.
it matched me. It checked, it verified automatically if
Mhm,
I was the same person. It
mhm,
even does that with a beard, and I don't know what facial points it takes. But
mhm,
my Aadhaar had a beard, and I didn't had a beard at that time, so it recognized me,
oh my
and
God.
I used it in December the next time.
Mhm,
I did not have to upload anything. I did not have to take a selfie or anything. I
mhm,
just have to connect my boarding pass to the application, to
mhm.
the DigiAtra application, and I could just go pass through it, and it recognizes me at the airport.
Oh,
Oh,
so
very
Digi
good.
aircraft application it is called?
DigiYatra.
Digi Yatra. Right.
Yes,
Yatra.
yes,
That's why public service usage of AI is very high. In fact, India AI they call it as that Chandrasekhar, who is our MIT secretary, he put
yes.
it. And this there was some AMSI, what is it? A national AI mission, something like that was in December.
January, Gaisa.
Gaisa. Okay, okay.
Gaisa, it was in, I think, 17th of January, 18th or 17th of January, something, at
Yeah.
some Maniksha grounds or something in Delhi.
Mhm.
Yeah, I wanted to visit that but could not. So yeah,
Yeah.
that's it. Uh, I also wanted to I don't know.
Mhm.
I'm just thinking out loud. But
Mhm.
what will be the effects, like in a video recommender system? What
Mhm.
will be the effects of adding more dimensions to it? Say, like for example, uh, I I as a person, okay,
Mhm.
I have a specific taste of for music.
Mhm.
Okay, but that music also has a lot of other dimensions which are non-musical. Say if
Mhm.
it is a film, then film will have its own dimensions.
Mhm.
Okay, the song will have, the lyrics will have its own dimensions. It will have a lyricist. It will have the language then,
Correct.
and the song will have a singer. So now there is my let's say my specific taste is I love songs which are sung by Bollywood singers, but which are produced by say Anirudh Ramchandar,
Mhm.
and whose lyricist is say somebody Ilya Raja,
Mhm.
right? So adding these dimensions would also help in giving more precise recommendations in the future.
Correct. Absolutely. You're on that. So basically, user input is very important. And if user can give input uh, on the label and the tags and the contacts, certainly it's faster to recommend something.
Yes, and also now coming to the point that Mamta Madam was talking about, right?
Mhm.
Uh, Having AI embedded into applications for medical,
Mhm.
we see a lot of things are already digitized, but
Mhm.
they are not on the network.
Mhm.
So the prerequisite is that we need to have devices that are on the network so that we could give the recommendations uh, on the fly, or in near real time.
Mhm. Mhm. That's
The
correct.
current system is like the mm,
I got it. I got it. So when the
ye-
doctor is actually seeing his image, the
yes,
device on which he is seeing the image itself should be on network, right? So
yes,
whatever he is pointing out is immediately captured and stored somewhere,
yes.
right?
So whatever, like suppose there is an operator who is operating a CT scan machine, and
Huh.
that machine is connected to this intelligent network, and
Correct.
we have a patient who is going undergoing a scan, and it says that okay, there is something that needs attention.
Hmm.
Okay,
Hmm.
maybe the image is not clear, maybe it would need a higher dimensional image to
Right.
have a good look at it. Say like a tumor is in the scale of, say it is less than a millimeter, right?
Hmm.
But it's
Hmm.
still a tumor. It is not detectable in a rapid scan.
Hmm. Hmm.
But when you focus on it, it might give you more insights into that specific tumor. I'm just taking a random, I'm not a medical person. If there is some,
I understand. Same is here. We're
yeah,
just applying our ideas.
yes, yes. So I think if that those devices are actually connected to the network, and like if they're connected to the network which is having this AI capabilities, then I
Hmm.
think it would be really more helpful than rather having it on the medical practitioner system. So
Hmm.
because
Hmm.
the person who is actually using is not a person qualified to give medical guidance or medical consultation, but
Yes.
he can give, if these devices are made intelligent by connecting to the network, the operator can have a immediate scan. Okay, I think like he see if the machine recommends that okay, there is a possibility of a clot in this area, in this region,
Hmm. Hmm. Hmm.
then the operator can again rescan with a higher resolution, density resolution, and he can give a better image to at the same time. So the patient won't have to go back and forth for diagnosis again.
No, I understand. That is actually exactly happening this way because I happened to go through MRI scan for my, sorry, sonography scan for my leg. I had some
Yeah.
pain. So that time what happened, I was in that MRI scan room and so the operator was operating the machine. And in that MRI scan, only the patient is there, nobody else is there, right? But the operator is in a nearby room where he is observing the entire image and the doctor was on the second floor. Because when I took that scan and went to the doctor, he said, yeah, I know this is the problem. I mean, before I showed him the image, he was already aware. And then he said that you have this problem over here. So I asked the operator to take a closer look at it. So
Okay.
basically, so it is already
Yes.
connected.
Yes.
The
See the
doctor is, in case radiologist is also online along with the operator and he gives suggestion. But what I liked about your suggestion is when doctor is pointing out something on his screen that needs to be captured live and stored
Yes.
as a video, not as a scanned image, but it should be stored as a video. That is what one point that you have brought in very correctly.
Yeah. Yeah.
For example, if there is something on a paper and I'm explaining to the student, okay, this is this, I'm just drawing randomly on paper with some pen or pencil. Whatever I'm drawing on paper, student has that paper. After I finish it, he can carry that paper. But while I was drawing and explaining and putting marks one after the other, that time itself it should be scanned as a image, as a video, not as a image. Right?
Right.
If it is a paper, it is an image. But when I am acting on it, it becomes a video.
Yes, actually, it would
And
give a more context.
everything.
It would give a sequence of how things are
Activities, yes.
processed.
Right, right. And
Yeah,
then whatever final point is there, maybe we can give, I mean, whenever the doctor has a display on it, we can put particular color pen or marking. So that becomes the actual region of interest. Because
right.
devices that we have are static devices. I mean, it for him it is just a screen. It is not a smart screen.
Yes,
So we need to do something that he gets a smart screen. So every time he is putting some mark on that screen, it is captured as a video. That
right.
should be should be done.
But
And
actually, the yeah, this medical is actually someone, as sir, as Prakash sir has already mentioned, like it requires some SME, a subject
huh,
matter expert, to
yeah,
have it, because it is a very highly regulated area,
hmm,
and the standards over there, they are like very rigid, and
right.
it really, if we need to propose a system, it should already be adhering to this
Their
standards.
standards. But
So
and besides that, one person cannot decide. It's a group of, like for example, whenever we go with some problem, doctors keep on recommending us from one doctor to another to another. That means we
yes.
can observe that there are levels of knowledge involved in particular part of disease, and then so two or three people together will come to the conclusion. So that kind of like smart image processing, image capturing, not processing, smart image capturing, sequence capturing, and then collaborate capturing. So all those things should be implemented. I mean, we are just talking, we are just talking on theoretical basis. But if somebody can do that, I mean, this point has come forward with this
Yes.
just one presentation. And
Yeah.
yeah, when you were mentioning about music, it just struck to me that when you're filtering the requirement, like for example, you say you like Bollywood movie, but written by so and so, but music by so and so. It is just one of the parameters. So is it a different dimension, or it is simply in a particular dimension addition of parameters? I
Uh,
see it as an addition of parameters in the same dimension.
so I was actually looking at music as one dimension and
Hmm.
movie as another dimension, right?
Oh,
Because
okay, 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 okay. So in that particular movie, you're talking of a particular song, and then by a particular set of creators.
yeah, because all of this, the songs will have all these dimensions, right? It will have its own properties also, but
Hmm.
we could look at this as dimensions. Like the lyricist is a dimension because he will have more songs.
Okay, 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 okay.
So in
Yes.
that sense, I think these would be dimensions.
Hmm.
Please correct me if
I think, shall I speak?
yeah,
Yeah,
yeah.
please.
Yeah, so I think what Nikhil is suggesting is that the system would implicitly get what his choices are, rather than keeping it as a parameter, I guess. Yes.
So I mean, it would be again like a recommender system only because okay,
Yes.
if I listen to three songs or five songs, then it would dive into other dimensions, have the data and relate it to me, to my user, to my
Okay.
and then we could have relations to the to other songs which are similar to, so basically having a clustering on multiple dimensions and then having a good intersection of all these dimensions to give better recommendation.
Okay.
Yeah. So both these are different, like seasons. Example, if you are watching uh, music, okay. Now you're talking about moving. It also could be like, oh, okay, this is December season and I'm going to South because there is a Carnatic festival, or I
Yes,
am coming to this Bombay because there is a Bhimsen or Tansen, whatever that, uh, and then could be some Hindustani somewhere.
yes,
So, so the music is very universal, you know.
yes,
Same thing with medicine. It is also medical is also universal. So the problem is unless you go to specific, like music system here will be different than in US or West. They will talk about jazz and all that. Here we will talk about some Bollywood or Collywood or some other wood, right? And they will talk about Hollywood. So there is a lot of knowledge which is pertinent to local and global. So it's tough, you know. That means there has to be database specific to that area. Same with medical. If you have for tumor, breast cancer, then diabetes, then what do you call, maybe digestive system. So each one system has to have a specific narrow down, and then in that context it will be able to operate. And then you can add to it other, uh, could be a explicit or implicit, and the variables that you give for the feature development. So usually, like example, what is the reason that Chat GPT or that has got billions and billions and billions of parameters? Because it is covering almost every subject, right?
yes.
It is so
Hmm.
hard to make. That's why it is easier to build a specific system rather than a generic system. And
True.
Gen AI, that is why it took 4, 5 versions,
Hmm.
one,
Hmm.
two. GPT 1, 2, 3, 3.5, Turbo 4, 5. So, uh, you see, every model runs through different, and that's why what I found is researchers generally take one particular, like example, I want to deal with, let's say, my nervous system and nervous system with respect to hand, then
Hmm.
left hand and right hand. They have got different um, whatever databases. So
Hmm.
what I found is these people take databases, ready-made databases are available, then use the transform, and then do their research and then issue papers. So they find it easy to develop and execute. If you go ground up, then it's a very hard task, you know. So yeah, but then simpler ones are uh, ones which just you use fundamental and knock out a basically public service, right? So if you look at India, how is India different from other countries? Simple, because India focuses on public service. Government encourages people to use AI for public service, and the public service includes health, telemedicine, tele operation, those kinds of things, right? So infrastructure, like if there is a breakage or something, drone-based implementation of what you call diagnosing a bridge being older or newer, is there going to be some cracks or something? So preventing that by fixing those kinds of things. So public service is what I find is interesting portion of India being ahead in this game. I wouldn't say that others are not, but they put lot of money and produce little bit less. Whereas India puts less money and more talent, and so AI will actually be a big winner for India because of the people, the skill set of our people. Yeah, I think I digress from the topic alone, but I'm just giving you what I was thinking. So,
That is
anybody? Yeah, go ahead, Mamta. Go ahead.
that is a very relevant point that you brought in.
Hmm.
Because we are a large population, we have a good data, a large
Hmm.
amount of data. And because there's a very large amount of data, in fact, we can be a better proposers for AI systems rather
Correct.
than anybody else in the country other than China. Right?
Correct.
So we should go faster with AI and ML so that we
Mhm.
become the leaders in particular area, not the other people leader, and then we follow them. We
Yeah,
have data, and data is a most critical component these days with research, right? We
correct.
because we have large population, we can produce large data.
So
So
projections are that we will have around 250 billion by 2030. That kind of a growth we are seeing in AI.
yeah.
So it's a
So then
tremendous growth we are seeing here. I
yeah.
think
So then
all these young kids, if they start applying AI in their own areas,
uh,
that will be
and
a superb change. And like the UPI system, payment system changed the whole country. I think
yeah, yeah.
this AI is going to really catapult us into a next generation. Definitely,
We
it is, and government is also encouraging. That is interesting. They
hmm.
are going after it full fledged. You propose a project which will produce something for public service, they will fund you.
Mhm. Okay, okay. Let's talk about it, proposing some project because
Mhm.
we need to bring in some money in the university also and do
Correct.
good job because
So, so that's why, Mamta, what I'll tell you is let Amina and Jaymeet interact, and if we are able to get some ideas where we can push, then we can propose something to even what do you call the health and human
uh,
services, so
right,
that
right.
and there are many what do you call uh, they call it as bits or they call it as research work. For research work, the funds are enough. You don't have
Hmm.
to even explain anything. All you have to fill the form and say, this is what I am and this is my projection. If somebody wants
Hmm.
to review, please review and approve it.
Hmm. Hmm.
So we'll
Hmm.
have to find out ways and means, and I'll explain to you as we go, because we need to really have good understanding. That is why I want collaboration from different colleges, how they do what they do,
Right.
because
Hmm.
it's too uh, put it this way, if you take any booklet, it will be in Hindi English combination, so I don't know whether it is English or in English.
Hmm.
Sometimes I have to struggle to figure out what it is,
Hmm.
and it's, and they write in volumes, 200 pages they'll use. Now 200 pages to absorb and digest and try to improvise on what area to focus on is not easy. It takes
Hmm.
time. So, Nikhil, what is your background? We didn't hear much about you. You spoke a lot of things. Where do you come from?
So I am from Mumbai,
Okay.
and actually I am more on the implementation side rather on research.
Yeah.
Uh,
Okay. Good.
so I am actually a software developer, and I have interests in IoT things, building
Okay.
IoT.
Hmm.
Yeah. So also other intersection is making something for public.
Mhm.
So I was actually thinking of maybe creating a radar-based system that is mounted on a vehicle to check the quality of roads and or the other was to have the same radar mounted on poles at distances to check the quality of roads, and that will also help to check water logging. If there is certain level of water logging, we could indicate the all the users
That
that
is
there is some
great.
water logging at a specific place.
So right now, what happens is we did one on mapping, if you remember, street
Yeah.
route map, and there the vehicle carries radars and lidars and all that, where they spot what is the traffic and
Yeah.
whether the cow is going to come in between or human is there, and that is autonomous vehicles.
Yes.
So it's called V2X and V2V.
Yes.
Maybe we can interact. Where are you located in Mumbai? Maybe we
Borivali. Borivali.
can.
Yeah.
So do me a favor, if you have an email, you send me your email. I can give you my email,
Yeah.
and
Yeah.
we can just let me give you. My email is pramchan at eotf.in. Okay, this is the organization mail,
Yes.
and if you interact with me on that, I'll be able to follow up with you. And
Okay.
because radar, lidar, V2X and V2V, and
Yeah.
those are communication areas which I have done. I'm a communication engineer from IT Bombay,
Okay.
so
Okay.
I can definitely give you subject matter expertise you need
Yes.
on.
Yes. Yes. Definitely.
Also logistics, I have we see I have, this is 40 years now career, so I have done transportation logistics, uh, transportation system. Also they call it dispatching and all. So when you dispatch a driver with a concrete and all, how they have to pour fast because otherwise it will
I,
freeze, right?
I
So
think he disconnected, Uncle. Oh, sir.
that's okay, so we'll catch up
Okay.
with it.
Okay. Okay.
I think we got enough inputs. So I will
Yeah.
say next time doing event recommendation systems, that is one thing which Mamta Madam pointed out, that you go into when you say stochastic gradient, what does it mean?
Yeah.
And also the complexity like logarithmic,
Yeah.
or it is linear, or it is something like order quadratic, those kinds of terms if you bring in. And that is why anyway you are going to do the advanced mathematics gate exam, right? So that we should be starting after the event, right? So this 17th we have an event, right? So after that we'll probably introduce in that. And Nikhil, welcome back. We were talking about you only since you left. Just go ahead and send me the mail and I'll follow up with you. Okay. I think he's in, what do you call,
Disconnected. Yeah.
he's connected, but he's in the mute. If you want to speak something, Nikhil, or
Yes.
send
Yes.
a mail, yeah, we'll
Yeah.
follow.
Yeah. Actually, I missed the email because I was just.
No, no, no. I'll rewrite again. Okay, okay. Put
Yeah.
your email otherwise, no problem.
Yeah.
You put your email also so that I can take it. Oh, sorry. This is not the one. This is something more. Okay. Okay. I'll take this off. P Ramchan at eotf.in. Yeah. And yeah, so you got it. And yours is
Yes.
Nikhil More 54
Yes. Yes.
at gmail.com. Yeah. Yeah.
I put
So
the image in our group.
which one? Which one you say?
I
Mamta?
have put
Anything?
the image in our group.
Yeah, yeah,
three names. So both of you get everybody gets their number. This.
yeah, yeah. I'll put it in the group. Okay, don't worry.
Yeah.
So I Nikhil More 54. See More, I remember More cricketer. I don't know. He used to play with Baroda.
Yes.
More.
Are you working with some industry or like is it a consultant kind of activity at your
Uh,
place?
Currently, it is a consultant type of activity, but I was a senior technical assistant at a DRDO lab, which is called LRD, Electronics and Radar Development Establishment.
Uh-huh.
So I
This was
have
in
con
Bangalore. This was in Bangalore, or this was DRDO
yes,
here?
yes,
Oh,
Bangalore,
Bangalore.
Bangalore.
Okay, okay. That's why you are able to visualize and say. That's what I was wondering. How come we didn't see you previously and you are already talking beyond what Jaymeet said? So, yeah, good. So,
Yes,
DRDO Bangalore, you were there. That is the reason. So,
yeah, DRDO Bangalore, but that was in 2005 or
mhm,
2006.
mhm,
So I worked there just for a year.
mhm,
I have worked with railways also. I was in the materials management department or the stores department of railways also.
mhm. Yeah,
And
railway has its own system. Railway has its own system for
yes,
signal and communication. Yeah, that's
right,
true.
right. But I think we could use this the you know imaging systems to track the the wayside assets, if what
Mhm.
they call wayside assets.
Yeah.
We could use satellite imagery or a drone assisted system
Mhm.
to track this. So because I was in stores, I know
Mhm.
the activity that they usually uh, take a train. The officials in railway, they take a train to estimate the amount of scrap that is lying on on the sides of the track,
Correct, correct. So,
or the condition of the bridges. If
mhm.
there are old bridges, if and they estimate how much of the weight could it be. So
Correct.
how much
So
of wrought
asset
iron. Yeah.
tracking, but asset tracking in an unconventional way.
Yes.
Normally, conventional way is to manually go watch and take photos and estimate, and this is like radar based and lidar based or some drone based, and just uh, like we take photographs in marriages and all, drone will fly and take all the photos. Same
Yes,
way,
yes.
it's like
Even
that.
if we could have something, because they are opening up this Bhuvan Maps imageries, we
Mhm.
could use it for you like create a single system that could monitor multiple cities and have a tracking of the specific game. Just take once, like to
Mhm.
begin with, take a single city,
Mhm.
not as big as Mumbai because it would be really difficult to.
I'll tell you, Baroda is a good place. The railway staffing center and
Yes,
at Pratap Nagar, they have got a very good this one. And Mamta, we can work with you to ensure that you can get something. And not only that, Nikhil can be brought in as a consultant or something so that he can drive the project and you can go along with that. And
yes.
Jamie, etc., whoever is participating, we can make a proposal like that. So, but let me work with Nikhil.
Also, yeah,
Mhm.
also we can propose that there is a new university of railways which is called
Yes.
Gati
In
Shakti
Baroda.
Vishwavidyalaya,
Correct.
In
GSV.
Baroda.
Uh-huh.
So we could try to have them also or collaborate with them also.
So Gati Shakti Vishwavidyalaya is in where?
It's in Baroda. It's in Baroda, but
Oh,
it's
Sati Shakti University is in Baroda and they are
oh
into
God.
recruitment also. Yeah. So
You
because
have a Mumta, you have the right person and the right
yeah, definitely. And
and
the railway staff college now is known as Gati Shakti. And they
no,
have
no, no,
converted
no.
it to
Railway Staff
university.
College is known as NAYAR, National Academy of Indian Railways, and Gati
But
Shakti
this,
Vishwavidyalaya is a new university of railways. It might be co-located in the same this, but it is a different university.
yeah, but
oh,
it is actually, I understand, railway staff college is primarily to train the staff, already employed staff. Whereas this
correct.
is a full-fledged, but it is on the same campus. That is what
Okay.
I want to say. Yeah.
So
Yeah,
so
it
we can
is.
do one thing. We can do one thing, Nikhil.
Yes.
First, please sit down and do some brainstorming
Yeah.
and come up with some kind of a proposal and then see engage with Mamta, Jaymeet and Amina and whoever is interested in that asset tracking area. So this
Yes.
has to do with First thing is it is asset tracking.
Yes.
Second, it has to be unconventional in the sense not manual but should be automated.
Right.
And the third should be it should be able to cut the cost. We have to show that by this you are able to cut the cost of assessment as well as not only they tag it right,
Yeah.
asset can be tagged, asset can be moved from one place to another. Uh,
Yes.
those are very very minute details, but we can even think of other technologies that can be brought in to speed up and
Yeah.
so algorithms and all. So we can put up a first thing is we have to come up with a proposal. What is the goal
Right.
and what are the objectives and how it is going to what are the business objective, what is the ML objective, like we have been Jaymeet has been uh, pumping this for now almost 6 or 7 use cases. So we can present a use case for ourselves within our closed door saying this is the system we want to build and see what are available comparatively and then come up with a precise cost estimates so that we can ask the proposal to be funded with part of the university doing the work and part of the consulting doing the work and combining the two and commercializing from what you call to from lab to uh, industry types.
Yeah.
Yeah, I think you have the right what do you call idea as well as we. I don't know it how it happened, but today it is a surprise to me that you came. Mamta also came and Jaymeet. So we do have a good meeting ground to try
Right.
something. I'm not saying that we may not be able to succeed. That's a different story. But we can attempt. Once we
Yes.
attempt, we propose. Then if it flies, then we have a story here. Correct?
Yes.
And then
Yes.
maybe you can translate into a startup. We have no problem with it because we know that that is how it works. Education system has to be able to produce the talents and help the talents, and the government should fund it, and they will fund it. Okay. The only thing is whether we can deliver it, and that depends on our what you call commitments.
Right.
So let us see how we go about it. At least we have got a good conversation today here, and I think I will stop here,
Yeah.
and we
When are
can
you
meet
planning to
offline
visit?
sometimes. Yeah.
When are you
Yes.
planning to visit India?